All right, welcome. In this video, we are going to talk through some examples of precipitation reactions, and we're going to write out different versions of those reactions. So both the molecular equation, the complete ionic, and the net ionic equation of various precipitation reactions that are right here in this recording here. So, okay. So first, we do a quick overview of what a precipitation reaction is. It is a type of double displacement reaction, and in a double displacement reaction, the reactants are both aqueous compounds. And notice in this pattern that A and X switch places, so the two cations will switch places with each other, forming two new compounds. And if a reaction occurs, then one of the products will either be a solid, a liquid, or gas. If you form a solid, we call this a precipitation reaction. And those are the type that we're going to focus on right now. And the different types of chemical equations, the molecular equation shows the complete compounds, so complete neutral formulas for every compound in the reaction. The complete ionic equation shows the species as they are actually present in the solution. So compounds that are electrolytes, we will show them being ionized, split apart into ions. And then the net ionic equation is going to focus just on the species that actually change during the reaction. Spectator ions are ones that are there before and after the reaction occurs and they don't change at all. So those we call spectators. Those are not included in the net ionic equation. And in order to figure out in a precipitation reaction which compound is my precipitate, is the solid, I need to know these solubility rules. So this might seem intimidating to memorize solubility rules, but no, there's only 5 of them to be aware of. So any compound containing a nitrate will be soluble. Anything containing acetate will be soluble. Alkali metal compounds will be soluble. Ammonium compounds will be soluble. And most chloride, bromide, iodide, so halogen compounds, are usually soluble except with silver, lead, and mercury. And then any compound that's not on this list of 5, we're going to assume is insoluble. So for example, calcium carbonate, calcium is not on my list of soluble things. Carbonate is not on my list of soluble things. Therefore, I will assume calcium carbonate is not soluble. All right, so let's stop and watch the video and write out a reaction here for this one. All right, I'm going to pull up this video. Hold on. There we go. Okay. Okay, so let's now write out the equations for this reaction. Here we go. The molecular equation is going to show everything as compounds. So I'm going to write lead nitrate as PbNO3. It's aqueous, and then potassium iodide is aqueous. So notice how we're given the formulas of our reactants. And then we know that when we have 2 aqueous compounds like this, they're going to follow that double displacement pattern, meaning the potassium and the lead are going to switch places with each other. So what that means is the potassium is now going to go with the nitrate, and the lead is going to go with the iodide. So notice how, whoops, I just wrote the elements next to each other. I have not yet filled in subscripts. To figure out what the subscript should be, I need to look at the charges of the ions. So if I look over at my ion charge reference page, then I will see that potassium has a charge of +1, nitrate has a charge of -1. So I actually don't need any subscripts in here. This is all good the way it's written. Lead, if you look at your ion charge reference page, you'll notice that lead is not one of those highlighted ions. So that means that lead actually has more than one charge of ion. That happens a lot with transition metals and also with some of these lower, heavier metals down here. Turns out lead can either be a +2 or a +4 charge. And so no worries, we can figure out what the charge is based on, sorry, let me find this page again, based on the original compound that it is in. There we go. So over here on the left, notice that one lead is combined with 2 nitrates. And I know that each nitrate has a -1 charge. Therefore, and I know these charges have to add up to 0. So therefore, my lead must have a charge of +2. So my lead has a charge of +2. Iodine, if I look on my table, that's one of the ones I know is always -1. So I need to have 2 iodines for every 1 lead. Okay, so now I've got my formulas written correctly with the subscript. My next step is I'm going to fill in the states of matter. So I'm going to use my solubility rules. I know that any compound containing a nitrate is always soluble. So that means that this is going to be soluble. So I'm going to write AQ by it. Iodide compounds are often soluble except when they're combined with silver, lead, or mercury. Lead. So lead, this is going to be insoluble. So this is going to be a solid. And then let's double check to make sure we're balanced with coefficient. So I have, whoops, I left a 2 out over here. There should be a 2 there. So I've got 2 iodines here, but only 1 over here. So I need to put a 2 in front of my Ki. So now I need 2 potassium. So I'm going to put a 2 over here. That also gives me 2 nitrates, but I already had 2 nitrates on the left. So now I'm all set. That's my molecular equation. All right, now let's look at the complete ionic equation. So things that will ionize are aqueous ionic compounds and aqueous strong acids. Those are the only 2 things that will ionize. These are what we call electrolytes. All right, so anything that's aqueous and ionic, I'm going to ionize it. So lead nitrate is actually 1 lead ion and 2 nitrate ions. And 2 Ki's, that's actually 2 potassium ions and 2 iodide ions. We are drawing them as they actually exist in solution. So my KNO3 is also going to separate into ions. But my lead iodide, it is not soluble, so it stays stuck together in that big solid mass there. So that's my complete ionic. And for your net ionic, you're going to look for spectators, things that are the same, exact same on the left and the right. So K+, NO3, they're not doing anything. They're spectators, so I'm going to leave them out of my net ionic. So my net ionic just focuses on the things that actually change in the reaction. And so that's, I have a lead ion and 2 iodine ions react to form lead iodide. And that's the actual precipitation piece of this precipitation reaction. These ions coming together to form this insoluble solid. All right, I'm going to pause the video here and I'll make some more videos going over the next reaction so you can keep watching if you want more examples and need more help on this. Otherwise, feel free to continue to do this on your own.